So hello everyone, this is Subodh Shah, and today we are going to study about vectors and matrix. So let us begin with taking a small brief about what are vectors and matrix. So students, in mathematics, vectors is nothing but representation of data which have both magnitude as well as direction. For example, suppose we have a student having his suppose we have a student and his height, weight, and suppose his test score is given to us, like the height of the student is 160 centimeter, the weight is 55 kg, and the test score is 90. So if I want to represent it in the vector form, so I can write it as 160, 55, and 90. Similarly, if I have the data of more than one student, like if we have another student having his height as 170 centimeter, the weight is 65 kg, and the test score is 85. And similarly, we have third student also having his height as 150 centimeter, the weight is 50 kg, and the test score is 95. So if I want to represent this data in the vector form, I can write it as 160, 55, 90, 170, 65, 85, 150, 50, and 95. So this tabular representation of data is known as matrix. So students, here in this matrix, each number in this matrix is known as element, having their unique positions. So let us understand that what are the position of these elements and how to locate these elements in the matrix. So first of all, understand that the numbers which are written horizontally over here are known as rows. So you can see that here there are three rows, and similarly the numbers which are vertically written over here are known as columns. So this is your first column, this is your second column, this is your third column. So this matrix has three rows and three columns. So student, these each elements or these each numbers in this matrix have their unique position, unique place. So if we want to locate this position of each element, uh, or to locate each element of this matrix, we have given name to the each position of this these elements. So here you have your first element. Since this number is written in first row and first column, so we denote it as A11, representing it as that this is in first row and first column. So similarly, the second element will be written as A12. That this means that this element is in first row and second column. Similarly goes for this third element, that is it is in first row, third column. Similarly for second row, first column. Similarly goes for 65, that it is in second row, second column. Similarly for 85 also, A23, and to all these elements, it will be written as A31, A32, A33. So while representing the position of each element of this matrix, we first write the position of the position of row of that particular element, followed by the column of that element. So just like that, this 160 is written in first row and first column. That's why we have represented it as A11. So this is how we represent the position of each element, and these help us to locate the elements of this matrix. So students, now let us understand what are the different types of matrix. Now, suppose if we have all the elements in single row, like 1, 2, 3. Here you can see that there is only one row in this matrix. We have three columns, but these all three elements are written in single row. So this type of matrix is known as row matrix. If all the elements are arranged in single row, then the particular matrix is known as row matrix. Similarly goes for column matrix as well. If we have all the elements written in single column, like 1, 2, 3. So here you can see that we have only one column. We have three rows in this matrix, but we have only one column. So this type of matrix is known as column matrix. Now suppose if we have a matrix which has same number of rows and columns, like 1, 2, 3, 4. Here you can see that here we have two rows and two columns. So since the number of rows and number of columns is same in this matrix, so this type of matrix is known as square matrix. Square matrix. And there are the many more types of matrix, but here we will be seeing only this types of matrix. Now, student, uh, let us understand what is the order of matrix, or how can you find the order of matrix. Or to find the order of matrix, what you have to do is just simply count the number of rows and column of that particular matrix. So for this matrix, we have only one row, and we have three columns in this matrix. So the order of this matrix will become 1 by 3. So how we represent or how we find the order of that particular matrix? We write, firstly we write the number of rows in that matrix followed by the number of column in that matrix. So the order of this matrix will become 1 by 3. Similarly, for this column matrix, here we have three rows and single column. So the order of this matrix will become 3 by 1. For this matrix, we have two rows and two columns. So the order of this matrix will become 2 by 2. So students, we write the order of matrix in the form of m by n, where m shows or m denotes the number of rows in that matrix, and n denotes the number of columns in that particular matrix. So students, now let us move towards various operations in matrix. So students, we have various operations in matrix. First, let us start with how we can add two or more matrix. Addition of matrix. So students, in order to add two or more matrix, what you have to note that or make sure that the order of all the matrix should be same. For example, if we have a matrix A of order 2 by 3, 2 by 3 means it has two rows and three columns. So we have its element as 1, 2, 3, minus 1, 2, and minus 5. And we have another matrix B. The order of this matrix or matrix B should also have 2 by 3. So let us suppose the element of this B matrix is 0, 1, minus 5, 2, minus 3, and again 2. So since the order of these two matrices are same, here you can see the order of both these matrices is 2 by 3 and 2 by 3. Then only you can add or even subtract this matrix. If the order of all the matrices are same, then you can either add or subtract the matrix. Then only you can add or subtract the matrix. So if I want to add, let us see how you can add or subtract this matrix. So if I want to add matrix A with B, what you have to do is just add the corresponding elements of two matrices. For example, here we have the first element as 1 and the first element is 0. So what you have to do is 1 plus 0. The second element is 2. Here the second element is 1. So it will become 2 plus 1. Here 3 and it is minus 5. So it will become 3 minus 5. It is minus 1. It is 2. So minus 1 plus 2. Here we have 2 and minus 3. So it will become 2 minus 3. Here we have minus 5 and 2. So it will become minus 5 plus 2. So the resultant matrix will be 1, 2 plus 1 is 3, 3 minus 5 is minus 2, minus 1 plus 2 is 1, 2 minus 3 is minus 1, and minus 5 plus 2 is minus 3. So here you have your resultant matrix A plus B. And the order of this matrix will be same. of same, just like A and B. The order of this matrix is 2 by 3. So this is how you add two or more matrix, or even subtract this kind of matrix. You have to follow the same steps, but you have to make sure that the order of these two matrix should be same. Now, students, let us see how can you subtract. I'm saying not subtract. How can you multiply two matrix? Multiplication of matrix. So as we have seen that to add or subtract two matrix, the order of both the matrix should be same. But while doing multiplication, it is not necessary that the order of all the matrix that you are multiplying should be same. So for example, you have a matrix A of order 2 by 3 having element 1, -2, 5, 3, 0, and 7. And we have another matrix B of order 3 by 2. 3 by 2. So the elements, let us suppose the element as 0, -1, 2, 3, -5, and 7. So here we have 3 rows and 2 columns. So if I want to multiply these two matrices, if I want to multiply A and B, what you have to do is just you have to find the to find each element of this matrix, you have to do multiplication of that particular row and column of that particular element. For example, if you want to find this first element, so what you have to do is multiply first row. The position of this element is A11. So what you have to do is multiply first row with first column. So here you have first row and this is your first column. So multiply corresponding elements. So here you have 1 and here you have 0. So 1 into 0 is 0. Then again -2 into 2 is -4 and 5 into -5 is -25. Now second element, to find second element, here you have A12. So you have, what you have to do is multiply first row with second column. So here you have first row and this is your second column. Now it is your 1. This is your corresponding element is -1. So 1 into -1 is -1. Here you have -2 and 3. So -2 into 3 is -6. And here you have 5 and here you have 7. So 5 sevens are 35. So this is your A12. Now student, understand one thing. This is your first element, so it was A12. This is your second element A12. Sorry, this is your first element A11. This is your second element A12. Similarly, I have not left any space for the third element. Why? Because there will be no element, no A13 element in this matrix. Why? What I have told you that to find A into B, what you have to do is multiply the elements of corresponding row with the corresponding columns of that particular element. So here, if I want to find A13, what I have to do is multiply first row with third column of second matrix, first row of first matrix and third column of second matrix. So here you have first row in first matrix, but you don't have third column in second matrix. So hence there will be no A13 in your resultant matrix. Similarly, if I want now my let us find the second element. The second element will be A21. So what I have to do is multiply second row with first column. This is my second row and this is my first column. So I have to multiply corresponding element. 3 into 0 is 0. Again 0 into 2 is 0. 7 into -5 is -35. Similarly, I have to find A22. So I have to multiply second row with second column. So this is my second row and this is my second column. Just multiply corresponding element. 3 into -1 is -3. 0 into 3 is 0. 7 into 7 is 49. There will be no A23. Now let us find A31. So what you have to do is multiply third row with first column. Third row of first matrix with second column of first column of first matrix. Second matrix. Sorry. You have to find A31. That means you have to multiply third row of first matrix with first column of second matrix. So in first matrix, you can see that there is no third row. So there will be no A31 in this matrix. So you have done with multiplication, just add or subtract the respective element. So -4 -25 is -29, -1 -6 -7 plus 35 is 28. Then it is -35, and 3 minus 6 minus 3 is 3. 49 plus 3 is 52. So here you got A into B, and the order of this A into B is 2 by 2. So here you can see that the order of matrix A was 2 by 3. The order of matrix B was of 3 by 2. But the order of matrix A into B is 2 by 2. But in addition, you have seen that the first rule of addition is that all the matrix should be of same order, and hence your resultant matrix was also having same order. But here you can say that see that while multiplying two or more matrix, the order of those matrix should necessarily be same. It is not necessary that the order of those matrix should be same. So here you got your resultant matrix, and the order of this matrix is 2 by 2. Student, here just note one thing, that without multiplying, even you can identify what will be the order of your resultant matrix. If you are multiplying two matrix having different order, without multiplying it, you can simply identify what will be the order of your resultant matrix. What you have to just do is your resultant, it is to note that the resultant matrix will be having order as, what you have to do is just take the number of rows in your first matrix and number of column in your second matrix. So here you can see that your first matrix is having two rows and your second matrix is having two columns. Hence your resultant matrix, that is A into B, is having two rows and two columns. So when you multiply two matrix, your resultant matrix will be having order number of rows in first matrix and number of columns in second matrix. So students, this is how you multiply two matrix. So far we have seen what are vectors, what are matrix, how can you locate the elements of matrix. Then we have seen three types of matrix. Then we have seen various operations in matrix like addition, subtraction, and we have also seen how we can multiply two matrix. So this is all for today. Thank you very much. I hope you all have understand what I have taught today. And if you have any doubt or any query, you can drop me a mail on subodhssh@gmail.com. Thank you.